In this video, we're going to write an assembly language program which reads values from the keyboard and then writes the values to the display. Now, once we've got this simple assembly language program working, we will then rewrite it using subroutines. So we will take the read loop, which reads the values from the keyboard, and we'll create a separate subroutine for this, and we will save this subroutine in the ROM. We will then take the write loop from the assembly language program, and we will write a subroutine for that, and we will save that subroutine in the ROM. We can then rewrite the original assembly language program so that it calls the subroutine for the read and it calls the subroutine for the write. Now, this is how a lot of programs will be saved within a CPU. So if there are particular subroutines which get used regularly, then we can just save those subroutines in the ROM and we can just call them whenever we need them. And it saves us continually rewriting the same piece of code. We just have to make sure that we're able to set it up properly so that the subroutine gets the correct input values. So that's what we will do now. So here is the code which we're going to use. Now, I have commented this quite a bit, so you can always go ahead and have a read through this yourself. But let's quickly go over it. We're going to have the origin of our program, which we've seen before. In this instance, it will be 0x8000 in hex, which is the first address in the RAM. Now, we're going to have this read loop, which reads the values from the keyboard, and we're going to have a write loop, which writes the values to the screen. So first of all, we're going to have the program written here as one long assembly language program. But before the end of the video, we're going to take this section here, which is the read loop, and we will create our own subroutine, and we'll save this subroutine in the ROM. So all we will need for this section here will be a jump to the subroutine. So it will jump to a particular address in the ROM which contains this subroutine. And we will also do the same with the write. Now, we've also got here the assembler directives, and we've used the EQU directive. So we've got 4 of them here. Now let's talk through the actual code. First of all, it's quite limited because we can only define a certain number of characters. So in this instance here, we can see we've got EQU1 and it's got num_character, and it's the value here which is written in hex. So the number of characters here is hex value C, which is value 12. Now, I've put this in because we're going to use the characters hello space world with an exclamation mark, and I know that's got 12 characters, so I've already set that up saying we're going to read in 12 characters. But of course, if you were going to choose a different set of characters and a different length, then you would just have to change this number to whatever value you want to change it to. So we're going to store the number of characters in register 1, and we're going to have to count down the characters. So we're going to start at 12 characters, 11, 10, 9, all the way down until we get to 0 characters. We're going to store the start address in the index register. So you can see here we're going to have EQU2 and it says character, it's 8024 in hex. So this is going to be the first address where we're going to store the hex value for the character. So we type in the keyboard and the very first character comes in and it goes into that address 8024. So these are the two bits of information we need before we can jump to the subroutine. Now the read loop here, we're going to load the value from the keyboard input, so that is we're going to read a letter from the keyboard into R0. Okay, so what we're going to do is the load command goes from memory to register, so the memory location is actually the keyboard input, and because we're using memory mapped IO, keyboard input is going to be this 0 cross FFF0. So we know when we use that memory location, we're actually pointing to the keyboard we are asking the keyboard for an input. So we take that input from the keyboard and we save it in R0. So this is going to be the ASCII value for our first letter. Then we take that value R0 and we store it in a memory location. So the memory location is given by the value in the index register, which is the first value here, 8024. We then increment the index register so that it now points at the next memory location, which is 8025, and we decrement the counter. So this is decrementing the number 12, so 12 goes to 11, so we'll now be on character number 11. We're going to clear the flags before we do any ALU operation. So this is an ALU operation where we compare the value 0 with the contents of register R1. So the contents of register R1 is going to contain the number of characters which we have still to read in. So if the number of characters that we read in is equal to 0, so if 0, then we begin the write loop. So that would have said to us, we've counted down all of the 12 characters, we've read in all of the characters. If you've read on all the characters, then you can jump on to the write loop, which writes the characters into the display. Now, if we haven't worked our way all the way down 12 characters, and we've still got some other characters to go, then we jump back to the beginning of the read loop. So this is the read loop here. And we continue with this looping structure until all of the characters have been read into consecutive memory locations, starting from hex number 8024. So now we're on to the write loop. Now in the write loop, again, we have to set up the number of characters. So we're now going to write these characters into the display. We need to know how many characters. Well, there's going to be the number of characters here again, which is 12. We save the value in R1. And again, the character start address we save in the index register. And then we work through this other loop here. So we load the index register into R0. So the character then goes into register R0 from the memory location, and we then store the contents of register R0 to a memory location. Now the memory location is the actual screen. So we've got the screen output. You can see the screen output is 0 cross FFF3. So we know via the memory mapped IO, if we refer to that memory location, what we're really saying is don't write to a memory location, write to the screen. So now we can write to that value to the screen. We increment the index register so it's now pointing at the next value in the memory location which we're interested in, and we decrement the counter for the number of characters. We clear the flags again. We then do the same comparison with the contents of register R1. Now, if the number of characters has gone down to 0, then we know that we've written all of the characters and we're ready to finish the program. So we jump if equals to the end. So here's the end here, so it jumps to this point here, and this loop here just contains end, so it just finishes the program. Now if it's not equal, we go to the jump and it jumps to this in loop here. So it goes to this loop here and it runs through until it writes all of the characters to the screen. So that's quite a comprehensive description of the little program. So let's go ahead and we will assemble it and we'll see it running. I have saved this file in the resources section, so you can open it up yourself and you can assemble it and then run it within the CPU. So let me just do the assembly phase here. So this is our assembler and we can run, and that's it finished with the assembly. Now I've got it set up here so it gives us a whole lot of information here. Now this might change, okay, so over time the output from the assembler, I will adjust it slightly. So you might not necessarily get exactly what you see on the screen here. But that's it run, and you can get in if you want and you can check it within the pass 1, so the first pass of the assembler, and this is the first pass here. Okay. Now once you've done that, you can go in and load it into the CPU. Okay, so that's us ready to now run the program. Now don't forget to actually type in your values. So I'm going to have hello world. Now I've slowed the CPU down a little bit, or I've slowed the simulation down a bit so you can actually see this operating. So go tick enabled and you can see it starting to read these values in. And each time here it's reading it into R0, so it's the value 6C, 6F, so these are the ASCII values for our hello world. And you can see it's counting down the number of characters. When this gets to 0, it will now reset and it will do the write. So this is us starting the write here, and you can see it's starting to count down the characters again, and it's writing these values to the keyboard, and you can see to the display, and you can see the values being written here. So when it's worked all the way through and this has got to 0, that will be us finished. And you can see that's the program ended now. So we have read the characters from the keyboard and we have printed them onto the display. Now this video has gone on long enough, so I think we will finish it off here, and on the next video we will take our assembly language program and we'll take the read loop and generate a subroutine in the ROM, and the write loop, and we will generate a subroutine within the ROM. So thank you for listening. I'll get you on the next video. Goodbye.